This time, we're heading off the beaten track.
I think we're going to start calling it a tank because it can withstand anything.
As we reveal the secrets behind a tough, go-anywhere 4x4, first imagined in 1948.
It's quite a dangerous process. There's always the danger of the material splashing by.
Unveil a game-changing military icon.
Whoa, we've got a water feature here.
And discover what happens when you take all-terrain to the absolute max.
The only place that this vehicle can't go is the sky because it doesn't have wings.
As we unearth the mysteries behind making the supercar of the off-road world.
It was a chance to be innovative, the chance to push the boundaries of people's thinking.
Designed to operate in the most remote environments on Earth, off-roaders are built to challenge nature. Originating from half-track military monsters and developing into four-wheel drive utility vehicles. Off-roaders soon became popular with the masses, sparking momentum with manufacturers around the world. From dune bashers to slope scalers and rock crawlers to overland racers. These rugged, chunky-wheeled machines are virtually unstoppable. Today, champion rally driver Catie Munnings is going to experience what happens when a classic off-roader meets modern technology.
So here it is, the new Land Rover Defender. First thoughts, it looks absolutely amazing. I'm loving how it's got the traditional heritage of Land Rover, but also combined with a really modern feel. I'm really excited to have this experience today. We're going to test out the car, see what we can do with it.
Tucked away inside each Defender is a breadth of mechanical and technological innovation that's been tested to destruction. A new aluminium monocoque structure makes it 3 times more rigid than traditional body-on-frame designs. Providing power is a choice of petrol, diesel, or hybrid electric engines. And cutting-edge sensor technology that makes those hard-to-reach places more accessible than ever. And Catie is going to find out just what this vehicle is capable of.
It is powerful. And when you think it's 2 tons, you know, it's not a light car to drive, but actually it's very responsive. It's not wallowy, it's not like a boat. It has got some kick behind it. It's obviously automatic, 8-speed gearbox. But it moves well, it handles the bumps well, it kind of just glides over them and then the dampers suck it up. They're all working independently and they're monitoring the body movement of the car 500 times a second, so it's incredibly active.
So how do you create a hardy off-roader with the spirit of a supercar? The secrets are hidden in Land Rover's purpose-built factory, located in the city of Nitra, Slovakia. This 300,000 square metre facility covers an area the size of 46 football fields. Costing £1 billion to build, its staff of around 1,500 work alongside 700 robots to produce a whopping 150,000 vehicles a year. Construction of each vehicle starts on the 90,000 square metre body shop floor. At the other end of the factory, a finished vehicle rolls off the line every 120 seconds. But before that happens, Chief Vehicle Engineer Rob Atkin and his team must create the beating heart of this new vehicle, the engine.
This engine uses all of the technology of regular supercars, but we use it in a very different way.
Instead of producing white-knuckle, record-breaking high speeds, Rob and the team need power at the opposite end of the spectrum.
We need to have great low-speed drivability and really good low-speed torque to enable the car to do what it needs to do when you're driving off-road. You can charge at things and you can get over most things just with momentum and enthusiasm, but you can create damage that way. So the more torque you have and the more low down you can produce that torque, the more capable the car will be.
Getting this combination of raw power and precision right is the secret to success. Started in 1948 as an offshoot of the Rover car company, their first vehicle, the Series 1, was an instant success, selling 200,000 units in a decade. By the 1970s, its tough, unstoppable attitude was being paired with more creature comforts, creating the Range Rover. And in the late 80s, along came the family-friendly Discovery, establishing the brand as a firm favourite with everyone from farmers to royalty. Over 70 years later, Rob is hoping that this brand new design is just as popular.
We had to evolve this car. We had to be respectful of the past, but we couldn't be constrained by the past. But we were always strongly aware of what the Defender meant to everybody and how this car needed to perform.
This starts under the bonnet with a selection of new advanced powertrains.
There are a family of engines in the new Defender. They're all made at our engine manufacturing centre in Wolverhampton.
With between 200 and 400 horsepower, these cutting-edge engines produce more torque than some supercars.
The Defender can go up a hill of a gradient of up to 45 degrees, so they're extremely powerful.
At Land Rover's test track, hidden deep in the English countryside, Catie's preparing to see if this 2-litre, 240 brake horsepower torque monster lives up to its predecessors.
Okay, so there's a wider field now. So here we can really think about the engine. I'm going to see if I can try and accelerate and see what it's got. Yeah, it's got some accelerating power. It's pretty cool.
Although it might not be winning any drag races, the raw power behind the four-wheel drive system is capable of towing the equivalent of 2 family hatchbacks.
It's quite manoeuvrable as well, actually. It's very responsive to the steering. It's also riding the bumps quite well, even at the high speed, which is quite impressive.
Pushing 2 tons of 4x4 across a flat field is one thing, but does this new power plant have the low-range torque necessary to deal with more extreme conditions?
Okay, so now we're going to test out the all-terrain progress control, and what that basically is off-road cruise control. So it's really useful when you're going over surfaces and you don't want to create too much wheel spin.
It's the ideal way to demonstrate the engine's capability.
So at the minute I've got it quite low, we're going up a steep hill.
If there's not enough low-range power here, Catie will never make it to the top.
I'm just letting it ride up the hill. It's quite steep, the car's working hard, it's putting itself up the hill at the same speed and it's staying consistent.
By monitoring the terrain every 20 milliseconds, the onboard computer takes over control of the throttle and braking, delivering the perfect amount of power to each individual wheel.
This technology is completely overwhelming. You know, in previous days, whenever I've been driving an old kind of off-road vehicle, you don't have this sort of support. It's all down to your feeling as a driver, because I would never have imagined you could have got up the hill by itself. So yeah, it's pretty cool.
Rob Atkin is the project's chief vehicle engineer.
For me, the standout feature of this car is how all of that engineering comes together, and it's a breakthrough for us.
This supercar 4x4 is over 4 metres long and almost 2 metres high. Adaptive dampers monitor the vehicle's body movement up to 500 times a second. And advanced air suspension ensures up to 7 occupants experience the smoothest ride possible. But when the tarmac runs out and the forest begins, the engineering challenges become exponentially tougher.
What we really have to think about is people will hit obstacles off-road. There's rocks, there's troughs, there's debris. If you get stuck, it's not a predictable environment.
So how do you ensure that 2 tons of highly engineered aluminium and steel remain as agile as a mountain goat and not a stick in the mud? It's a secret that couldn't be unlocked without a game-changing wartime innovation.
Go!
Ex-Special Forces mobility instructor Titch Cormack is in the Cornish countryside, revealing how a 1940s military vehicle became an off-roading icon.
In the mid-20th century, warfare had become far more mechanised, and the military decided what they needed was a new vehicle. Something light, something agile. What they needed was a mechanical horse.
It took manufacturer Willis less than a year to produce the ultimate off-road ready design.
And this is what they came up with. A vehicle that became world-renowned as the Jeep. It's fantastic to drive. I mean, it feels really agricultural. It's very simple. It's all bare bones, it's minimal. But that's the beauty of it. Whoa, we've got a water feature here.
But what it lacks in creature comforts, it more than makes up for in performance.
And look at that little beast in there. This is a 2.2 litre, 4-cylinder, 60 horsepower engine. Now, it doesn't look a lot. It looks quite small in comparison to modern day engines. However, it's a cast iron block. This is super robust. It'll never wear out.
And with almost 9 inches of ground clearance and impressive approach and departure angles, when it comes to obstacles, there's not much this off-roader can't handle.
When I talk about approach angle, this is how steep a bank you can approach and you can then get traction on. If you imagine that my bumper was down here, like with a normal car, I would only be able to approach something like this. The bumpers are really high, so actually I can approach a bank at an angle of that. Superb.
Quick, nimble and seemingly indestructible, the Jeep became a battlefield hero, capable of every job, from weapon carrier to frontline taxi.
I'm going to try and cool off with a bit of wind in my hair. So I'm away, and we were away in 2-wheel drive.
In 2-wheel drive, the power from the engine is delivered to just the rear wheels via the drive shaft.
Why have 2-wheel drive when you've got 4-wheel? Well, what it does, it lightens the load on the components, on the drive shafts, on the joints, and lightens the load on the engine. However, it's not that capable in the wet and the mud and the off-road. Oh, she's spinning up now, she's spinning up now.
Which is no good when you're out on the battlefield.
No, no, no. You don't want to go.
The solution? Send power to all 4 wheels.
We need to engage the infamous 4-wheel drive. Let's see what it does. She's gaining traction and we're off again. So as I've discovered, the absolute saviour is to be able to drop the gearbox into a lower ratio, and then we've got the 4-wheel drive that we can kick in. And that just absolutely pulled it out the bag. To think this is 70 years old and it's achieving this, it's phenomenal. This was a real game changer in the 4x4 world. And if it wasn't for this little Jeep, we wouldn't have such cars as the Land Rover Defender we have today. And it's awesome fun.
Today, the 4x4 is no longer reserved solely for the military. And although the furthest this new Defender might make it behind enemy lines is a trip to the supermarket, that doesn't mean it's lacking fighting spirit.
So this bit ahead here is pretty boggy, so we're going to have to keep some power up to get through it. It's impossible to create wheel spin with this car.
At this specially designed off-road proving ground, expert rally driver Catie Munnings is pushing its four-wheel drive capability to its limits.
So you've really seen the all-wheel drive response there, coming up through that mud. That was slippery, but all of the wheels were working independently to really power the vehicle through it. I don't know many vehicles that would have got through that. Just a gentle throttle response, constant throttle pressure, which is also managed by the active systems, and we were able to navigate our way around that really nicely.
This advanced technology allows it to cross some challenging terrain.
I can see up ahead now, we've got some water.
But what happens when it needs to get wet? Very, very wet. The secret behind its aquatic ability is the sensor technology.
So there's one sensor up here, which is a mid-range camera. At the front of the car, it has a long-range radar, and it also has traditional ultrasonic sensors, and here it even has vision cameras. Those vision cameras are then plugged into our near-field sensing system that can provide visualization of the car surroundings. Once the car understands what its surroundings are, it can perceive whether it needs to take any action. So, for example, it might choose to correct your steering if it detects you're veering out of your lane. The driving assistance controller determines whether it needs to act every 20 milliseconds, completely unnoticed by the driver.
Not only does this sensor technology keep drivers safe on the road, it allows the car to perform the ultimate off-road turn.
So let's imagine we've got a water crossing. We can go into the wade sensing platform. The ultrasonic detectors will tell us how deep the water is. So the suspension lifts. The powertrain mode is set to a more progressive mode to get you through the water. And even the air recirculation for the cabin is turned on so water's not ingested.
Back at the off-road test track, all it takes is the push of a button.
What I have to do is put a terrain mode straight into wade.
And it's transformed into 2 tons of four-wheel drive river wading supercar.
This is absolutely surreal. It does feel like you've kind of got waves beneath you.
Ultrasonic sonar sensors located underneath the door mirrors constantly monitor the vehicle's depth in the water.
This now is like being on a swamp. I'm expecting to see an alligator sat there on the banks. This is properly deep here. It's like, yeah, this is pretty cool.
It's capable of carrying out this engineering feat up to a depth of almost a metre.
This is ridiculous. I mean, you know, it actually does genuinely feel like a boat. When you think about it, my feet are underwater now and it's muddy. And underneath, we're not driving on tarmac. It's rocky, it's rutted.
Combining this new technology with its four-wheel drive system means it can go deeper than any of its predecessors.
Okay, wow, yeah, that was awesome. I can't believe it can go that deep. I can see the watermarks out of my mirrors. That's insane.
Defender is an iconic nameplate. There's a lot of people who were looking forward to what that new car would be. We had a sense of responsibility, but we were very confident we knew how to develop the car into the new vehicle for the new era.
This all-new design comes in 2 wheelbase lengths with either 3 or 5 doors. Front and back are 4 super tough 18-inch steel wheels. And adjustable suspension that allows it to clear an obstacle as tall as a wine bottle. But to be able to endure punishment from even the most novice weekend warrior, engineers must ensure that the new model has one overarching attribute: strength.
Because it's going to do a lot of extreme things off-road, that puts a lot of load into the car. We've really had to think carefully about what metals we use, what design we use, and where we use them. So we always put the right material in the right place.
So what makes this new model stronger than its predecessors? The secret lies in how you turn raw metal into a finished 4x4. At this factory in Lancashire, engineer Nick Smith is revealing the secrets behind 100 years of metal casting.
Okay, so I'll show you the raw material that we start with, aluminium ingots. So that's an ingot, a couple of kilos there. There's various grades of aluminium that we can use, different properties for different types of parts.
The lightweight, high-strength properties of aluminium make it the perfect material for structural elements on off-road vehicles.
So here we are in the bulk melting room. We've got our ingots, we've transported them to the furnace, and now we're going to melt them. Obviously, it's quite a dangerous process, loading the ingots into the furnace. There's always the danger of the material splashing back. Furnace is set at 780 degrees. You're looking at about half an hour in this type of furnace for the ingots to melt.
The next task involves turning this raw metal into a complex chassis part using a process called high-pressure die casting.
So this is the high-pressure foundry. In here is maybe 1,000 kilos of molten aluminium.
The giant die casting machine uses hydraulic pressure to inject liquid metal from the dosing furnace into the mould.
If you imagine a big piston that will push that material into the mould in a very controlled manner. The secret to successful high-pressure die casting is control. Control of the injection of the metal, control of the temperatures, control of the rate of heat transfer. If you've got one weak link, then you've got a problem.
The high pressure holds the metal in the mould until it solidifies.
What will happen then, the mould will open automatically and ejector pins will push the casting out of the side of the tool.
A robot grabs the chassis part from the mould and plunges it into a bath of water to cool. The casting is then placed into a trimming press where any excess material is removed.
Essentially, that is the cast part. All the bits of runner have been removed, so we're getting towards the saleable part now.
Lastly, these trimmed parts are transferred to the finishing department to be pared to perfection.
So what we're going to do here, we're going to put it through a blasting process to blast away any sharp edges off the casting. And what it also does is put an even surface finish on the component.
After a 5-minute shot blasting cycle, the high-precision chassis components are ready to leave the factory.
So this is the casting after the final process. What we end up with is a beautiful looking, nice shiny die casting. So the part is now ready to go to the customer for use on a vehicle. Just to see the end product like this, with a lovely finish like this, I'm very proud.
In Slovakia, robots piece together dozens of die-cast and pressed aluminium parts to form the super tough skeleton of the Defender. And although it may look similar to its predecessors, underneath it's been completely redesigned for the first time since 1948.
So the previous Defender was a body on frame, which meant the aluminium body sat on top of a steel frame. For the new Defender, the most efficient answer is to have a monocoque.
A monocoque design simply means that the body and frame are created as one structure.
We chose the monocoque because it's just the most efficient way of getting the performance and the weight you need to deliver what this car needs to be.
Central to the monocoque's strength are its cast aluminium parts.
So this entire part here is cast, and we do that because it has to carry an extremely high load. This tyre can weigh up to 45 kilos, and the load that that transmits as the car's travelling down the road needs to be managed by the strength of this part here. The advantage of the stiffness of the monocoque is the car is just tough and strong, but it feels really strong when you drive it. It has great integrity. It feels unbreakable.
Back at the test track, rally driver Catie Munnings is preparing to see whether Rob's engineering is as good as he claims.
But I'm really keen to experience how strong this platform and the chassis actually is.
To do this, the engineers have created an off-roader's worst nightmare. The chassis crippling Concrete H. Designed to test components to their ultimate limits, can this new monocoque design resist snapping as it's put to the ultimate test?
It is so manoeuvrable. There's no flex at all. There's no roll through it. Nothing's breaking so far. And I'm able actually to get all the wheels in the air. I cannot believe that. Look at that. Honestly, apart from the fact that you're in the air, smoothness-wise and bumpiness-wise, it feels no different to just driving down the road. Is that not ridiculous? This is the time of my life. I cannot believe it's doing this. It just shouldn't be happening in a vehicle. It should not be possible. It's defying the laws of science. Incredible.
Back at the factory, there's another engineering secret behind the new all-terrain conquering system. The vital link between the monocoque platform and the wheels. This replaces traditional coil spring suspension found on older off-roaders.
So the air suspension offers us great advantages in terms of ride. Also, it gives us an adjustable ride height. So this car can now lift up to a ground clearance of 291 millimetres. But it's got a hidden secret. If you're travelling through, for example, mud and ruts, and the car detects that you're starting to belly out and lose traction with the tyre, we have a feature called Auto Extend, and the air suspension can actually press the tyres into the terrain harder, up to about 40 millimetres, without the driver doing anything.
We're just coming into some trickier conditions here.
Off-road, this adjustable ride height should allow Catie to tackle tough terrains, but is it up to the job?
Here, I need a bit more ground clearance, so what I'm going to have to do is I'm going to have to raise the suspension. So that means I've got to stop, and then I select the raise suspension option.
At the push of a button, the air suspension is raised by up to 75 millimetres.
It's got a system which is adaptive, which means it's actually monitoring the body movement of the car up to 500 times a second. So it's constantly changing and constantly adapting to the terrain, so that it really soaks up those bumps without you feeling too much in the cabin. And the car is just kind of completely managing itself. There's no slip in the wheels, there's no loss of traction. It's not at all jolty. Obviously the damper's softening the blow as well when it returns to the floor. Wow, I was impressed with that. That was pretty cool.
Taking inspiration from the original Defender, first built in 1948, this redesign features a side air intake that allows it to wade in almost a metre of water, as well as 14 ultrasonic sensors and 4 wide-angle HD cameras, each providing a 190-degree field of view.
All of this technology under the skin is really the secret of what makes the Defender.
But what happens when you strip away this technology and push the off-roading concept to the ultimate extreme? Deep in the Canadian wilderness is a vehicle like nothing else on Earth.
This vehicle is like an off-road on steroids. Every time I get into this thing, I'm excited to drive it.
And today, 4x4 technician Larry Posberg is putting it to the test.
So this is the Sherp. The only place that this vehicle can't go is the sky because it doesn't have wings.
Capable of tackling practically anything nature can throw at it, this off-road titan is designed to speed over swamps, slice through snow, and swim across ice-covered lakes with ease.
In winter, these things are absolutely amazing. So ice that's breaking, the Sherp has no problem with whatsoever.
Effortlessly blitzing obstacles from massive boulders to fallen trees, the Sherp can overcome just about anything that gets in its way.
I have never driven anything as capable as the Sherp. Pretty much where everything else stops, that's where Sherp begins. I mean, this is stuff that even Jeeps and other utility vehicles can't handle.
The gutsy Russian-designed Sherp is the brainchild of engineer Alexei Garagashian and the result of 20 years of development.
This is actually an engineering masterpiece. The part that makes the design so successful is the fact that it's lightweight, it's very structurally strong, and all of your weight is low. And with the footprint of these big tires, it makes the machine unstoppable.
These tyres are at the heart of the Sherp's terrain-chomping abilities.
The tires have a very large paddle formation, and when you're driving on water, what it does is it's rotating very fast, and it's causing a forward pull with the paddles.
On land, the secret to keeping the big wheels rolling is a self-inflating and deflating system which adjusts the tyre pressure to match the conditions of the terrain below.
These tires can drop down and work almost like tracks to conform to the environment that they're crossing. Without these tires, you wouldn't have half the capability.
It all adds up to a machine that's unstoppable.
I mostly enjoy driving the Sherp in either swampy or extremely muddy areas where I can actually put this thing right to the limits.
But there's one thing the Sherp is missing. That's a steering wheel. So how do you control this marauding monster?
So you steer the vehicle by operating one stick or the other stick. So if you want to turn to a left, you do this, or vice versa with the right turn. By the looks of it, there isn't a brake, but when you pull back on these sticks, you've got left and right braking.
This combination of fearless capability and engineering innovation puts the Sherp in a league of its own. And in 2017, it proved its endurance by completing a record-breaking 10,000-kilometre expedition across the Russian Arctic.
Oh, I absolutely love this. Every time I get out in a Sherp, that's a good day. I would say, in my mind, the Sherp is definitely the most extreme off-road vehicle. It can absolutely go anywhere where we need it to go. I have the best job in the world, no question.
The Sherp may be well suited to traversing extreme wilderness, but it isn't ideal for day-to-day motoring. In Nitra, the final touches are being applied to the new Defender, including the complex electronics that power the vehicle's brain. But the engineering team face another challenge, one that's hampered off-roaders since their creation. The solution to this problem can be found hidden deep within the vehicle's body.
If you imagine we're driving along rough ground and one wheel encounters some slip, you can lose drive and traction. So let's simulate that. This wheel has really strong contact with the ground, lots of grip. That wheel is in the air or on some slippery surface, low friction, and you can see that all of the power of the engine is being sent to the wheel with the least resistance So we counteract that slip and that loss of traction by using a locking differential. This is an electronic differential.
By locking the electronic differential, the car is able to ensure that power is always making its way to the wheel with traction, no matter how challenging the environment becomes.
So this is now locked, and you can see in the same scenario, I'm winding the car forwards, I'm applying some load to the right-hand wheel. The wheel that's in the air is still turning, but it's turning at the same speed as the wheel with traction.
But what does it feel like when you're behind the wheel?
I'm very used to kind of looking at a car and thinking, right, okay, I'm going to have to drive it like that to get there. In this car, I can kind of just sit back and let the systems take over in a way.
Back at the test track, Catie is feeling the full effect of this electronic differential.
I think one of the coolest points is just watching the diff lock and unlock. As a driver, you know, there's not a particular skill that I'm having to put into the car. The car is adapting, there's no slipping. So now we've reached the flat again. You can see on my screen here, both diffs are completely unlocked. It's because we've got grip, there's no need for them to be locked. If it gets slippier, maybe we'll see one start to lock.
The electronic brain behind the differential scans the road surface every 20 milliseconds, and with 6 pre-programmed setups, handling anything on or off the beaten track isn't a problem.
So if you have a look here, I can show you, for example, grass, gravel, snow program selected. And here you can see there's a different automatic setup for the diff. When we started moving there, it said that the front one was semi-locked and the rear one was open. That's because you want a bit of slip still. You want a bit of wheel spin on snow to keep the momentum moving. That's really cool. It's actually difficult to not spend too much time watching it and keep watching where you're going on the road. A bit like playing a computer game, sometimes you forget that it's actually real life as well.
The engineers at Land Rover have combined over 70 years of off-road engineering secrets into a machine as versatile and as practical as a Swiss Army knife.
This vehicle handles like nothing I've ever driven before. I was blown away by what it can do. The way that we could throw one wheel up in the air, how deep it could go in water, and all of the active systems as well. I've literally never experienced it in a car.
It's a vehicle built to tackle just about any terrain on any continent.
The real reward comes from watching other people pushing this car to its limits and telling us how much they love it. And that's a hell of an achievement, and it really makes us feel proud.